Hi everybody, thanks for coming today. So I'm Patrick Chanazon from Docker, and we're giving this talk with Ville Haig from Accenture. And today we're going to talk about Docker for AWS and how it helped Finnish Rail modernize their ticket app. Why this talk is interesting, we were talking with Ville about how many people there was in that room today and wondering what brought all of you here. And the reason I think is that the two most interesting revolutions that happened in software development in the past 10 years were AWS creating the cloud computing market in 2006, and then Docker creating the containerization movement 4 years ago. So now we're 11 years and 4 years into these two revolutions, and it's not people usually know about the technology, but what they're curious about is how other people are using it. And so today we're going to talk about the #1 container platform, Docker, on the #1 cloud platform, AWS, and how that helped a customer, Finnish Rail, modernize their application. So let's talk about trends first, why Docker was so successful. One of the main reasons, and I'm using that weird acronym from Adrian Cockcroft, who's now at AWS. One of the things he used to say when he was at Netflix is that one of the goals for his team was to lower what he calls the MTBAMSH, the mean time between an idea and making stuff happen. And to me, that's one of the big trends that started 20 years ago with agility. Now that everybody's using agility, and Docker is a very good tool for making your teams more agile. And what this means is that agile means for developers to create more business value as opposed to shaving yaks and managing infrastructure. The second trend that's more recent, that's more like 5 years old, is called DevOps. DevOps is a cultural movement. It's inspired by Agile, but it brings the ops team in there. It's not only about technology, it's also about people, processes, and tools. And it's about a set of practices like continuous delivery, infrastructure as code, collaboration across silos, and having small iterations between devs and ops, and having that feedback loop between production and development when you're measuring things and then you enhance the application as a result. Who among you are trying a DevOps approach in your company? Yeah, lots of DevOps practitioners. So DevOps has a real transformational effect, and one of the numbers that represent that the most to me is this number. In 1999, an ops in the Windows world would manage 5 servers. And a sysadmin in the Linux world would manage 50. It was much more automated. In 2015, in large organizations like Google or Facebook or Microsoft, or Amazon, one ops is managing typically 10,000 to 20,000 machines. And in order to get to that level, you need to automate a lot of things and to create a platform on top of self-managed infrastructure. So let's talk about why IT departments are interested in containerization. One of the reasons is that typical IT departments spend 80% of their budget in maintenance, and then only 20% left for innovation. And at the same time, in the past few years, they got to manage, in average, 8 different numbers of platforms, whether cloud or on-premise. And that led them to spend all their time and resources in maintenance, and they don't have time for innovation. At the same time, business models are being changed in most industries by software. Every company is becoming a software company, and so the IT departments are asked by the business to start doing more innovation. So one of the questions they have is, how do I find the right budget to do innovation when I spend 80% of my budget on maintenance? So the Docker platform provides such a platform that allows you to modernize traditional applications and accelerate the delivery of existing applications on a common platform. The three main attributes of it are portability. So Docker works on-premise, on virtualization, as well as on any cloud providers. So it's a very good platform for hybrid architectures. Agility, typically developers who use Docker ship twice faster. And then security, containers add one layer on security on top of the existing infrastructure that you have, whether it is bare metal, virtualization, or cloud. But at the end of it, it also reduces the total cost of operating your infrastructure by 50% because containers can be more dense. About Docker, the company, so Docker started the containerization movement 4 years ago. It's been very successful. There's today 21 million Docker hosts around the world. The number of container downloads from Docker Hub is at 24 billion, and it's growing exponentially. And the number of job listings listing Docker as a skill grew tremendously at 77,000%. I don't know if we should use percent in there. And Docker is built on top of industry standards. So in the past 2 years, we worked with lots of other companies with the Linux Foundation in 2 initiatives, the Open Container Initiatives, where we created a standard for container images and runtime called OCI, the Open Container Initiative. We're going to talk about that in a panel tomorrow evening about Amazon and open source. And then the Containerd project, which is an implementation of these standards that's part of the CNCF, the Cloud Native Computing Foundation. So Docker is a platform that sits on top of standards and open source. Docker is we're selling our platform to lots of different industries. So you can look at service providers, healthcare, financial services, tech, it's all over the place. And today we're going to talk about an example in the transportation industry with Finnish Rail. Docker container basics, I'm sure, who here has been using Docker? Okay, so most of you, so I won't belabor this one. So Docker containers are application level tools where you package all your application and your dependencies, but you share the same operating system. So it's much more lightweight than VMs. And it works for Linux and Windows. So the way we build Docker, it all starts in open source with what we call the Moby project. Over the past 2 years, we did a very big effort in componentizing all the pieces that we built Docker from. So having some reusable components that can be worked on independently. So for example, Containerd is the core container runtime. We have LinuxKit that allows you to build small Linux distributions, InfraKit for infrastructure management, HyperKit to manage VMs on a Mac, and so on. There are like more than 12 different components in the Moby project. Then in that project, that's our upstream to build out of these components a Docker Community Edition that's targeted at developers that you can find on your Mac or PC, so Mac or Windows. And then Docker Enterprise Edition that's really more targeted towards enterprise users who want to deploy containers at scale and manage them with all the security, access control, and the different rules that enterprises need. Docker Community Edition is designed for developers. So you're typically using that on a Mac or Windows, and it's an assembly of lots of different components. So here you have an example of a diagram that shows the architecture of Docker for Mac. When you install Docker for Mac, you just open a DMG, install an application, and then you open a terminal and you can type Docker commands. But behind that, behind the scenes, there's a lot of magic happening. So we're using the hypervisor framework that's native on the Mac through a component called HyperKit. And then we have VPN-Kit that connects the network of the Mac with the network of the Linux VM. We're using LinuxKit for the Linux component in there. And then there's the Docker container engine in there, and there are lots of different components assembled into a package. That's what we're building at Docker. And then Docker Enterprise Edition, it's the same thing, but for the enterprise. So it's designed to be deployed on clusters, and it provides a lot more, a whole management layer with role-based access control. You can choose your orchestration framework. At DockerCon this year, we announced that we're supporting now Kubernetes and Swarm in Docker Enterprise Edition. You have a Docker Trusted Registry to manage your images in a secure way. Docker Content Trust to sign the images. You have a whole policy engine for promoting the images to production. And Docker Enterprise Edition is certified on a lot of different infrastructure. And then on top of that, you can run certified plugins for volume or networking and certified containers that are coming from Docker Store. So let's talk about Docker Enterprise Edition on AWS, which is what Finnish Railway has used to modernize their application. So Docker Enterprise on AWS is a deep integration between the Docker platform and the AWS platform. So we're integrated with a VPC for networking, with EBS for storage. We're deeply integrated with the Elastic Load Balancer so that when you create a Docker service with Docker Stack Deploy, the load balancer is updated automatically. We're integrated with EC2 and scaling groups for the Swarm workers and the Swarm managers. And we have a CloudFormation template that helps you get started with that. And then to modernize your application, the journey is pretty simple. You start with an existing application that could run on bare metal or virtualization. Then you can use some tools to automatically convert that into a Docker container. You don't need to touch your code at all. And then once it's converted into a container, you put that into Docker Trusted Registry, and then you can deploy it on modern infrastructure like Docker for AWS. And after that, you can set up CI/CD and use a more modern DevOps methodology. And then you can start modernizing your application by adding microservices to it. And so in order to explain how Finnish Railway did that with Accenture, Ville is going to tell you about their adventure.
Thank you, Patrick. Wow, so many people here. I mean, even though that the Finnish Railways has 150 years experience in transportation business of deploying containers, even before the Docker, nobody would have guessed a few years ago that the Finnish Railways is going to present in reInvent. I think that you soon realize why. Why so? Because the landscape and the IT infrastructure has changed a lot after adopting AWS and Docker technologies in Finnish Railways. My name is Ville Heg. I work at Accenture as a technical architect, and why I am here today is that the client unfortunately wasn't able to join us today. But I have helped the client to build this application platform, as well as I have participated in renewing of their few core systems, one from the mainframe and one was running in Oracle stack to the modern microservices-based architectures. Few words about the Finnish Railways as a company before we go to the application platform. Basically, there is three main business units in Finnish Railways. Passenger traffic, logistic, and the track. The track is basically building tracks and maintaining them. Train operations is more or less people, conductors and drivers, and the maintenance is just taking care of Finnish Railways fleet. We are actually talking quite big Finnish company here. So basically turnover is a little bit more than 1 billion euros and the headcount is around 8,000 people. And actually Finnish Railways has one of the most accessed online sales systems in Finland. So let's talk a little bit about the problems they had in past. So in past, actually, these business units have had their own IT organizations. some of those applications they are hosting are really old. They are basically mainframe systems, and some of them are a little bit newer, but they are running in different runtime environments, and they are a little bit that there isn't clear processes how these applications relate with each other and how they are developed and deployed. So basically, the Finnish Railways IT landscape, there wasn't that kind of a big picture anymore. Nobody really understands how these applications, there is hundreds of applications, hundreds of integrations, how they relate with each others and how they are actually running into production. So basically they were also missing the visibility what's happening in their systems. Also, there was many vendors, many different vendors. Finnish Railways isn't developing any applications in-house. So basically, vendors are developing all the applications. And Finnish Railways didn't have the visibility of what kind of processes these vendors are following, and are they doing all the best practices when they are developing applications. So, in addition to this, every application was hosted in the traditional local data centers. So these were the main reasons why they started to think that something needs to be done. Everything started about 3-4 years ago when they decided that they are going to replace their one of their core systems, reservation systems, which was running in mainframe, to something else. So at that stage, they started to evaluate different options, different technologies, how this reservation system should be done in future. At the same time, they have an idea that it's not just about the reservation system. We should do something else for those a little bit modern applications as well. And they started to build a business case around this change. So if you think about that, you are going to board of directors and say that, hey, I found this cool technology. I want to start to use it. It will solve anything, everything. Of course, the head of directors are just looking with the blind eyes and say, no, next. But when they started to actually started to build a business case around this. So basically they started to find what kind of drivers there could be, and one of the biggest drivers from the business side was that the bang for the buck. So basically they wanted to reduce their costs a lot, and Finnish Railways did a calculation what it would mean that if we are going to move these applications from data centers to the cloud, what it would mean that if we are changing the proprietary solutions to the open-based solutions, what it would mean that if we are actually trying to reduce our maintenance costs. And for that, they came up to the figure of 40% cost savings. And it was something that actually was easy to agree by the head of directors. We are reducing our cost by 40%. Can we go? Yes, you can. Also, there was an important business driver, so basically they wanted to improve quality, they wanted to improve time to market, since in past application development was really slow, and the deployments could take hours, and if something goes sidetrack, it would take even days. So they really wanted to improve the time to market. Also, there was important IT drivers. So basically, they wanted to have a common application platform as well as the unified architecture to get some kind of visibility what is happening in production, in their environments, to get visibility what is happening in different vendors, what kind of processes they are following. As well as reduce this cost by moving to the open source based solutions, and for those systems which are completely rewritten, basically they wanted to adopt it microservices-based architectures. And DevOps, of course. We are living in a modern world, and containers should, and microservices should use DevOps approaches. Let's take a look a little bit at what has happened in these 3 years. So Finnish Railways was a traditional company. IT development has been really slow. So actually, in 3 years has happened a lot. First, they invested to after they got the idea, they invested it to the DevOps platform, and they started to create this migration business case for basically taking those a little bit modern legacy applications, changing, for example, their WebLogic application server to JBoss and package them to the container and deploy to this platform. And creating a business case around this rewrite of those mainframe-based solutions. About a year and a half ago, the first Docker platform was created, as well as the AWS accounts. Those accounts were really simple. Basically, they created one account for development and one account for production. And it was manually done by using the AWS console. Soon they realized that something needs to be done also to how to manage this AWS infrastructure, and they started to rework the account structure and introduced infrastructure as a code principles as well. First system on top of this application platform went live on June. It was the commuter traffic online sales system, and the big thing was that on August, when this reservation system, which started this thing, went live. So basically, they opened some champagne bottles and started to celebrate a little bit. And first of these kind of migration applications where they just changed the application a little bit, the package in the container went live a few months ago, and at the moment they are continuing to migrate 20 more applications. So really much has happened in 3 years. So when we are talking about the application platform, so basically we have had 3 cornerstones what this application platform should be. So basically it should be consistent. So whatever you deploy to this application platform, we are guaranteeing that it works, there isn't any surprises, as long as it is Docker container. So you can deploy any container running, for example, Node.js, Spring Boot, JBoss, you name it, and package it as a container and deploy it to this application and application platform, and it works. Also, it needs to be unified. So unified architecture means that basically all of those core capabilities should be same for every application. For example, logging and monitoring and metrics should be the same. And you can deploy any container and you get those features out of the box. And last but not the least, everything needs to be automated. Whether it's application platform, whether it's AWS infrastructure, whether it's application itself, everything needs to be automated as much as possible. Like I said, a year and a half ago was the first AWS account created. Since then, the pace has been really fast. So basically, at the moment, Finnish Railways has more than 20 accounts, which are all integrated with the ADFS to company login portal. So basically, users can log into the company login portal and then get access to the AWS account. They have, at the moment, more than 100 RDS instances, and some systems are actually using DynamoDB for application persistent. Computing power, more than 300 EC2 instances, 50 of those are for this Docker platform, and some applications are actually implemented by using Lambdas. This is the account structure they are currently having. So basically, they have different accounts for non-production workloads as well as the production workloads, as well as they have separated accounts based on their logical usage. So basically, they are running consumer-facing solutions in one account and this Docker platform in another account. And of course, they have at the moment, we are running in Ireland, but then they have different accounts, for example, backups and logs, which are running in different regions. All of these accounts are integrated with the existing Finnish Railways infrastructure by using Direct Connect, And everything you can see here, whether it's account, whether it's some AWS service running inside the account, whether it's the platform applications, they are managed by infrastructure as a code principles. So basically they have written, and we have written Terraform scripts to get this infrastructure automated. In case if something happens, we just run the Terraform scripts and we get the new accounts and services in place in just a matter of minutes. It's not just a basic accounts and core services. Also, by adopting this AWS and Docker, the application development has become really fast, and the usage of the different AWS services are really easy for the application development work. For example, we have applications which are sending mail by using a simple email service. Some of them are using queues. We are using SQS for that. And also there is interesting things coming on in roadmap. For basically, Finnish Railways is looking to adopt big data and real-time analytics, which bring elastic MapReduce and the Kinesis into the mix. Now let's talk about the Docker itself and the application platform. Basically what you see here is the Accenture reference architecture for container platforms. In Accenture we have a quite long history working with containers and container platforms, and we know what kind of capabilities it needs to run and operate successfully these platforms. The key message here is that actually the Docker EE itself is a really robust product and provides most of these capabilities out of the box. For example, if you need to registries, there is a DTR scheduling, of course, as well as the secrets management is provided by Docker EE. Of course, there is a few places where we had to introduce additional capability and using, for example, third-party vendors. For example, logging, we are using Elk Stack, and the metrics and monitoring is provided by Sysdig. So, like I said, there is a different workloads running in this platform. Of course, there is a non-production workloads, which is basically the development and testing environments. There is hundreds of containers deployed. New ones are deployed in every minute, and there is lots of things coming and going. In the middle, we have these greenfield exercises. So basically, modern microservices, they are mostly at the moment Spring Boot stuff. And of course, we are running these legacy workloads where we are taking those old applications, modernize them a little bit, and package them container and deploy to this application platform. And every one of these workloads are running in the same platform. Here is the AWS infrastructure for the Docker EE. I know that you might not see anything about this picture because it's so small, but basic idea is that all of those core and critical components for Docker EE, for example, workers, DTRs, UCPs, HRMs, they are deployed. One instance is deployed at least to every AZ the island has. Of course, we are also utilizing the auto-scaling groups. We are utilizing S3 buckets for images saved to DTR, as well as we are using ELBs, EFS for those containers which needs the file persistence capabilities. And this is managed by Terraform scripts. So if something happens for the cluster, we are just running the Terraform scripts and we get the new resources available and new cluster available in 20 minutes. When I'm talking about the cluster, we actually have a few different clusters. At the moment, development and testing cluster are the same, but we are going to change it so that the development cluster is different than testing cluster. Just because of that, if something happens in the development, it doesn't stop the testing, or if something happens in testing cluster, it doesn't break the development. At the moment, we are running two clusters in production. The idea is that one is kind of hot cluster, which will receive all of those 100,000 requests per day, and the other one is code cluster. So basically, it doesn't have any workers assigned to it, and if something happens for the hot cluster, we actually just ramp up the workers, new services and stacks gets to deployed, and then we just switch the ELB to point this new cluster or code cluster, and the production doesn't get any long hit. After we have changed the ELB, we can either fix the old cluster which had difficulties, or then just recreate it from the scratch by using Terraform scripts. Now that we had made really great infrastructure, we have a really great application platform provided by the Docker EE. The next thing was that we had to think about multi-tenant capabilities. We knew that there will be lots of projects, there will be lots of teams working in this platform, so we wanted to make sure that they can do their work as easy as possible, as well as they shouldn't interfere with each other. So basically the answer was quite simple. Docker EE integrates really well with the AD. So basically, whenever the new team starts, we just create new organization in AD, introduce one technical account by which the team can manage the deployments, and the information flows to the Docker EE itself. After that, the team can control whatever resources they need. If they need to create stack, services, networks, they can do it. We aren't limiting anyhow. For example, if the team needs one network, it's fine. If it needs 5 networks, that's fine. Team can do it. When it comes to routing, so basically, each of these clusters have a big domain name, and based on the naming conventions, we are splitting a subdomain for each of these teams. So when the request comes in, Route 53 first routes it to the HTTP routing mesh, which then routes the request to the container serving the request. Secrets management, actually we are using and recommend using secrets management also to save configuration values, because it's a really nice feature. So basically Docker EE itself is capable, when you declare the secret into the platform, Docker EE makes sure that the secret is injected to the container actually needing it, and it isn't exposed to any other containers. Of course, we had to add a little bit scripting around the secrets management to get it fully automated from the development to the production, but it wasn't any magical. DTR, yes, we are using DTR. We are saving those images to S3 buckets, but the idea is that the basic idea is exactly the same than with the rest of the UCP stuff. Basically, the team controls what images, what repositories they need. We are allowing them to create as many registries as needed. Image scanning and signing, it's a great feature provided by the Docker EE. It's at the moment on our roadmap. We have played with it a little, but we haven't yet finalized it. But we will take into use as soon as possible. It provides additional guarantee that whatever needs to deploy to this platform is properly scanned and properly signed, and it's safe to get deployed. Well, it's not just about creating magnificent platform. We also spend quite a lot of time to make sure that the teams can start to develop as easy as possible, as fast as possible. So I know that everybody hates to read user guides and manuals, and it's even worse to write those. But actually, we did quite a documentation around the platform and its capabilities. So basically, we declared the naming conventions, how these tags and HRM or images should be named. We create manuals how to do load balancing or use secrets management, as well as we created reference patterns and the cook books. For those are a little bit more complex use cases, but we write those down how to use them in real life in this platform. For example, if the application needs the EJBs, enterprise beans. So basically we taught them how to enable layer 4 load balancing. If the application or microservice needs to run multiple versions in production, at the same time we described how you can do it, what kind of compose files you need to write, what kind of naming conventions you should follow, how do you do versioning. Or if they need some kind of a file persistence, so how do you take EFS into use and start to use file persistence capabilities? It wasn't just about documentation. We actually create kind of reference applications. So basically those were a little bit simple hello world type of applications, but basically they showed the structure of the application. They demonstrated what kind of compose files it should use, and based on those reference applications, the new team can just copy-paste them, change it a little bit, for example, change the names, change a little bit of their own application configuration, and get it up and running in development environment with no time. It wasn't just the reference applications, as well as we created the reference pipelines. So basically now that the team has application running in their local workstation, we showed what kind of pipelines is needed and what kind of steps it is needed to get this application run in the test and even in production. So basically the teams can copy-paste the reference application, copy-paste the Jenkins tasks. We are using Jenkins for CI/CD pipelines. Copy-paste those tasks and get their own application or their own microservices deployed to the production. And in good day, it shouldn't take more than 2 to 3 hours for the team to get their magnificent new service to the production. Also, we are providing common base images, CentOS, JDK for those Spring Boot-enabled microservices, JBoss, as well as these local images. For example, if the team needs to develop their application, which is using the DynamoDB, we are providing local DynamoDB image, and they can pull it from the DTR and start to use it, as well as the Redis and Memcached. This is our reference pipeline, and it's simple as it can be. It includes all those steps what you can imagine. There is a build test phase, there is also publish phase and deploy phase, and deployment to as many environments as you need. Basically, we are using build nodes. Those are just EC2 instances where we have installed the Docker agent, and we are building against those machines. The idea is just to get a little bit load off from the UCP and the development cluster itself. Then comes to the testing phase. This is nothing magical. There is unit test, integration test, UAT tests, performance tests. All of them are automated, and if those are passing, we are just publishing the image to the DTR of the target environment. After that, we are just deploying the stack, Docker stack to the target environment, and the service gets to deploy there. When it comes to the promotion to the production, all we have to do is just to pull the image from the test environment DTR, retag it, and then push it to the production DTR and deploy the stack. It's really simple. A little bit scripting, and that's it. One of the main drivers from the IT perspective was to have some kind of visibility what is happening in their Finnish Railways systems. And we spent quite a lot of time to figure out what is the best tools and what kind of capabilities it needs to operate this platform successfully. And those tools should be able to take care of all of these workloads that they are having. For example, logging. We created a guideline that when it comes to the logging, the application needs just to produce their logs to the standard output, and then we have a syslog agent which is capturing those logs and pushing them to the elk stack. Elk stack then provides the capabilities, for example, to index those logs, provide the easy search for those logs, and provides, for example, the access control of the logs. For example, teams can't see another team's logs, and also we had a special requirement to produce audit logs, which are just visible to some roles. Monitoring and metrics, we are actually using the same tool here. When you are running this kind of containers and using container platforms, so basically there is magnificent kind of traditional monitoring tools available like Zabbix. But the problem is that with these containers was that using Zabbix with the containers isn't the best match. For example, you need to configure it manually and you need to, or then script and do all kind of magic because containers are coming and going. We ended up to use a product called Sysdig. And the good thing in Sysdig was that it's container native. So basically, all you need to do is to install Sysdig agent, which is actually container itself, to each of these worker nodes running in this cluster. And after that, the Sysdig agent integrates to Linux kernel and starts to produce lots of metrics and lots of data from the worker node and all of those containers running in that worker node. This data is pushed to the Sysdig cloud, where there is a good dashboard, and to drill down what is happening, you get lots of data, basically with zero configuration out of the box by using this Sysdig. For resource management, basically whatever gets to deploy to this platform, we demand that there should be some kind of limitations in Docker Compose files. For example, how much CPU this container can use, how much memory it can use. Basically, the idea is that one 40 container doesn't take down the whole worker node. But we are just using Docker Compose to fulfill this resource management requirement. And then again, whatever gets to deploy this application platform, whatever type of the application it is, as long as it's Docker, you get all of these capabilities out of the box. VR is using, like I said, there is at the moment 3 applications which are modernized, packaged as a Docker container and deployed to this platform. And we are actually, Finnish Railways is actually using Accenture Container Factory for that. Accenture Container Factory is, there is 2 things. There is one is kind of documentation, processes, and the other one is the people. So basically, we have done together with Docker the best patterns and best practices, how to modernize applications, how to use and how to deploy them to the Docker EE platform. We are also providing base images if needed, as well as we have a Docker methodology and reference architectures available. This is type of paperwork and kind of framework which is allowing us to do application migration projects predictable, repeatable manner without no surprises. But it's not just enough. Also, you need the people to do these things. And basically, we have trained, or Docker has trained, more than 500 people in Accenture to use Docker EE platform and know how to do these application migration projects on top of Docker EE. So basically, whenever there is a new application modernization project starting, we just ramp the people up and they already know how to do this thing. They know what kind of practices should follow and how to use the platform. So it really has helped the Finnish Railways to modernize and migrate these legacy applications to a little bit newer versions. Few things of the lessons learned in these three years. One of the lesson was that when you are selecting the technology, trust the selection, because of course there will be hard times, there will be a little bit surprises when you are adopting the new technology, but basically most likely you have selected the technology and you know that the other clients are using it. So trust that instinct and trust your choice, because usually it's not about technology. The biggest thing actually was that how many of you have been in an organization which is trying to adopt a DevOps approach and DevOps practices? Was it easy or hard? I guess it was hard, and especially in Finnish Railways case, when we are talking about the traditional organization and the DevOps is changing the whole organization from the top to the bottom, everybody needs to start to understand what is this modern DevOps ideologies, what is modern DevOps technologies, and how they change your work. And it was the one thing that the client wants to change in this program. So basically they wanted to change that you can't communicate enough of what is happening, how your work is changing, does it change at all, and keep people on track what is happening. Also, like I said, adopting containers, it's easy. Senior developers most likely can start to use containers and Docker or already know it, but keep in mind also those junior teams and pay attention to this work which is needed to enable the application development as fast as possible. So basically we are talking about these reference architectures, reference pipelines, and documentation and cookbooks. It really helps those junior teams as well as it helps the senior developers in a way that they know what kind of capabilities there are already, how to use them, so that they don't start to reinvent the wheel. Last but not least, these modern technologies, whether they are AWS, whether it's Docker EE, they are evolving really fast. For example, Docker EE is releasing every 3 months new version, which contains new cool features, which contains a little bit fixes, and so on. So make sure that you can start to use those new versions as soon as possible when they are released. So basically, I'm talking about automation here. During these 3 years, I think we have installed, I guess, 5 major Docker EE versions. So let's get back to those drivers we had at the beginning of this program and what was actually the outcomes here. The biggest thing was the bang for the buck. And we came up to the number at the beginning that the IT cost should be reduced 40%. The actual number and the actual cost savings was actually 50%. So basically we exceeded our target. Nowadays, Deployment times, basically they are minutes. They aren't anymore days, they aren't anymore hours, they are minutes. And basically we are doing the rolling updates, so there isn't any service break in production. So basically nobody notices that there will be a new version in the production, except the end users, which are just amazed how many new cool features there is. Also, the automation is now a really core part of our processes and our pipeline. So basically, we are automating everything which we can. And at the first time almost in Finnish Railways history, we actually have a unified IT architecture and visibility what is happening in the production environment. And it is really huge thing for the Finnish Railways IT organization. So basically, the platform is the same, the component and processes are the same. Only thing which is changing and hopefully is changing are the applications on top of this platform. So together with the AWS and together with the Docker EE, Finnish Railways has really increased their efficiency in application development work, and they can start to migrate these legacy applications out from the data centers to the modern technologies and modern cloud, as well as enable, if the new applications needs new features, those can be easily taken into use by using AWS services. So basically, they have really nailed their IT development and application development processes, and they have got a really good efficiency, both in development as well as the business cost savings. So they are really happy of this platform and how it has been done. We are staying here. We don't have any official QA session now, but we are staying here at the corner with Patrick if you have any questions. I know that this was really high overview of what Finnish Railways has been doing and what kind of application platform they had, and it was just a scratch of the surface, but we are staying at the corner if you have any questions. So please come and ask. Thank you.